All right, in today's video reference, we're going to learn how to graph linear inequalities. So the reason you see a lot of highlighting is because part of the method is that you have to, after you make your graph, you're going to have to shade, which we just saw from some of the videos we just watched. So let's jump right into basically, this gives a good example of how you could test whether or not something is a solution. So if we want to test if these coordinates are solutions to our graph, the first thing you want to do is probably get this in slope-intercept form. So if we're going to solve here for this y like we've done in the past, what's the first thing you would do to both sides? Minus x. You're left with negative 3y is less than or equal to, how do you write this side again? Negative x plus 6. Last step, divide everything by negative 3. And then you're left with y is less than or equal to 1/3 x minus 2. Okay, so now let's test some of these points, and we want to see which one's not a solution. So again, these are our x's, these are our y's, and we want to see which one is not a solution. And basically, when we're kind of looking forward, that means if it's not a solution, you're not going to shade that part of the graph. And if it is a solution, you would shade that part. So most common one to always start off with is 0, 0. So if I plugged in 0, 0 here, I would get 0 is less than or equal to negative 2. Is that true or false? It's true. So that is a solution. So 0, 0 would be shaded here. The next one, if I plug this in, is negative, let's go right, I guess, here to b. So if I put negative 1 in, is less than or equal to 1/3 times 6 minus 1. So I'm left with negative 1 is less than or equal to, what's a third times 6? That would be 2 minus 1. And 2 minus 1, let's double check that, is 1. So negative 1 is greater than or equal, less than or equal to 1. And that is also true. So that would be shaded. Let's keep going here. 10(3). So if I plug in 10(3), this would be 3 is less than or equal to 1/3 times 3 minus 2. So let's see if that one is a solution. So this would be 3 is less than or equal to 1 minus 2, which is 3 is less than or equal to negative 1. That's actually false. So this one's not a solution. So basically, in this graph, your solution set would include 0, 0, 6, negative 1, but not 10, 3, or negative 1, 2. So moving right on to graphing them. Basically, it's pretty simple. You just graph the inequality as if it's just a linear equation. So this will set the boundary limits, divide the coordinate plane into 2 halves. And as you saw from the videos, raise your hand if it's less than or greater than. What kind of line do you make? Yeah, dashed line. And then how would you know if it's a solid line? Yeah, it's going to have less than or equal to or greater than or equal to. Usually the test point that you always use to test whether or not it's a solution and which part to shade, you always use 0, 0 in my opinion. And shade the solution that has the coordinate plane. If it's not a solution, then shade the other half. So I think we saw from one of the videos, and let's test this theory. I think if you keep your y variable on the left, and then if it's greater than or equal to or greater than, raise your hand. How do you always shade? Should it be above the line or below? Yeah, above. And then let's test this theory here. If y is less than or y is less than or equal to, how should we shade from our boundary line below? So let's see if this works for today's video reference example. So first example here, it's already in slope-intercept form. Where do I start? Negative 5. And how do I move? Down to right 1. and then up to left 1, like this. Raise your hand. Is this going to be a dotted line or a solid line? Yeah, it's definitely going to be solid. Okay, so if our theory holds true, this is greater than or equal to. So should we be shading above or below the line? Yeah, above. But let's test 0, 0 to make sure it is part of the solution. So when I put 0, 0 in there, is 0 greater than or equal to -5? The answer is yes. So you're going to grab your hand fancy highlighter, whichever color you like, and you're going to just enjoy the satisfaction of highlighting above this line, like that. All right, let's do another example here. Turn to the next page, our video reference here. Okay, so this one, just a little bit more, as Miss Hindle likes to call it, housekeeping. We have to solve for y again, so it's minus 2x, and what's my equation? Y is less than negative 2x, plus 5. All right, so before I even graph this, raise your hands. It's going to be dotted or solid? Dotted. All right, so let's start at 5. Down 2, right 1. 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 Then we make a dotted dashed line here. Again, anything on this line is technically not part of the solution set, so that's why it's dotted. Okay. Theory holds true. If it's less than, should we be shading above or below? Yeah, below. So in this case, will 0, 0 be part of the solution set right down here? Yes, it should be. So let's double check that. So 0 is less than 5. That is true. So you can just go ahead. I'm going to use blue this time and shade that here. Something like that. All right, example 3. All right, now we got our vertical and horizontal lines. So raise your hand. Is y greater than 1 or just y equals 1? Is that vertical or horizontal? It's horizontal. Someone want to use the laser to kind of go over that line on the graph? Yeah, hopefully you went here. Put a line here. Is it dotted or shaded? Should be dotted. So we'll go here. Put a dotted line. Okay, so if it holds true, greater than, should I go above the line or below? I should go above. So will 0, 0 be part of my solution? Hopefully not. So is 0 greater than 1? No. So you can again shade this time in pink, shade above the line, like so. All right. And then the last one is example 4. Raise your hand. Vertical or horizontal for x equals -3. It's vertical. And then raise your hand one more time. Is it dotted or shaded? I'm sorry, dotted or solid? It's solid. So hopefully you know that you're going to put your line at -3. This, just for an extra koosh, is that a slope of 0 or undefined? Undefined. Perfect. All right, so if it holds true, this is kind of weird because we'll have to think about this. Less than, because our variable's on the left, you want to go less than, you want to go below the line, right? So there is no below this line, but what do you think would be below the line? In this case, would it be right of it or left of it? My guess is left. To be honest with you, I don't even know. So I'm going to throw in 0, 0. And basically that just makes my x equal to 0. And so then I'm going to have 0 is less than or equal to -3. So is 0, 0 part of the solution? No, it's It's not. So I was right. So in this case, less than means shade to the left. So that one you might want to always just test it. But I'm guessing if it's less than and it's a vertical line, you're going to go to the left. And if it's greater than it's a vertical line, you're going to go to the right.